Well, in this video, we have one theorem to look at and then one example. The theorem, which we'll call trapezoid median theorem, given a trapezoid, a line that bisects one leg and is parallel to the base contains the blank. So it's a line, infinite line, bisects one of the legs. So here we have the two bases, they're parallel. These are the two legs. So if it bisects this leg, make that the midpoint of that leg right there, and it's parallel to a base, either one, because remember the two bases are parallel. So it's a line. It's actually a line. I could have made it a line segment, but it says a line, so we'll keep it that way. A line that bisects one leg and is parallel to the base contains the median. The median is this line segment from here to here. So it contains the median. So that tells you that if you take the midpoint of one of the legs, draw a line through it that's parallel to one of the bases, it'll be parallel to both of the bases, you will hit the midpoint of the other leg as well with that line. Okay, and here's a little formula we need to remember. The length of the median from here to here, the length of that line segment, is 1/2 the sum of the lengths of the two bases. What's another way of saying that? Well, here's what we normally write it like 1/2 of b plus b. We usually say capital B is the length of the longer base, and little b is the length of the shorter base. Another way of saying that is it is the average of the lengths of the two bases. So it will be, the length will certainly be in between the length of the smaller base and the big base, and it'll be exactly in the middle. 1/2 big B plus little b. And something, I think we've already said this, the median, this segment from here to here, is parallel to each of the bases, to each base, the long one and the short one. Okay, now we have one more example to do. In this trapezoid, ABCD, so we'll go with the way I drew it. It appears that we have AB parallel to CD. These are the bases, and then AD and BC will be the two legs. They are not parallel, but AB is parallel to DC. Label E as the midpoint of side AD. So let's put the midpoint there, and let's call that the point E. And label F as the midpoint of BC. Right there. Okay, and I'm probably going to need to connect it, so let's go ahead and do that. So EF is the median of that trapezoid. Let's label K such that, what does this mean? K is in between D and C, which means K is going to be somewhere on this line segment here, but we need to make AK parallel to BC. So we're going to go, I want to make a line segment parallel to this. So how about that? That's pretty close. So that's going to be my point K. Label the intersection of two line segments. If they intersect, they're going to intersect at one point, and we're going to label that as G. EF, that's the median, intersected with AK. We're going to call this point where they intersect the point G. And let X be the length of the side EG. So EG, we're going to call this side length X. that little line segment there. And we're going to call y the length of GF, so that's y. So you could say that the entire median, EF, is equal to little x plus little y, those two lengths. All right, we're given a little bit of information here. If AB, the length of it, is 20, let's go ahead and write that. And if DC, the length from here to here, the length of that whole side, the big base is 28, then find x, y, and EF. Well, once we find x and y, we know that EF, the length of EF, is going to be x plus y. So x and y are the things we need to find first. Okay, let's start by inspecting the parallelogram. And what is the parallelogram we're going to look at? Well, we know that AB is parallel to CD. These are the two bases. And we created AK, this segment, parallel to BC. So A, B, C, K. That's the parallelogram we're going to inspect. Let's find KC. KC, that's actually going to be very simple. Since this is a parallelogram, we know opposite sides have the same length. So this length here is 20. So KC equals 20. Now we need to find DK. Well, that's very simple as well. The length from D to K, well, I know the length from D to C, the whole bottom base is 28, and here's 20 of it from here to here, so that's got to be 8. So DK is equal to 8. Now we find X using the midpoint connector theorem for triangles. Remember now, this is a median of the triangle. Remember what the property is for the median of a triangle? Actually, it's not I should have made it a little bit lower if I wanted to make it look just like the median. But this segment is the median. Well, that median is parallel to the base, and it's also half the length of the base. So if the base is 8 of this triangle, X is going to be 4. So maybe I'll write that in there. 4. 4 is X. Now find Y. And I'm reminding us that KC, oh no, not reminding us, we haven't even observed this yet. KCFG is a parallelogram. We know this median is parallel to the base, and we know that this side is parallel to this side. So this little parallelogram here, if we want to find y, we know that opposite sides are congruent. So we know that y is 20. Y equals 20. Okay, we found x, we found y, and the last thing we have to find is the length of EF, which is the median of this trapezoid. Well, it's just this 4 plus this 20. So I'll even write it. 4 plus 20 equals 24. That's the end of the problem, but let's answer this question. Is EF what we would expect from the trapezoid median theorem? Well, do you remember what the length of the median is in a trapezoid? We would expect it to be 1/2 the sum of the bases. Well, the bases are 20 and 28. 20, 28. So 1/2 of 20 plus 28, that's half of 48, that's 24. That's exactly what we got. The length of the median of the trapezoid is indeed 1/2 of the sum of the two bases. 28 plus 20. 48 divided by 2 gives us 24. So yes, it's exactly what the midpoint or the trapezoid median theorem gave us.